you could always just, go to this equation, plug in x equals b to the t, and, solve it, and then go backwards, by the substitution. But many times this is much quicker, okay? Just assume a solution of x to a power. Yeah.
So for these, for case 2 and 3, we're still doing like the C1 and C2?
Oh, yeah, exactly. Because that's the superposition principle, it hasn't changed. That superposition principle holds whether it's constant coefficients or variable coefficients. Okay. So let's just do just a few of these, okay? And I guess when I do the video on Friday, I'll do the remaining ones which I haven't done, okay? And again, when we finish this topic over here, the Cauchy-Euler, which will probably happen Friday, that's what the test will cover, and I'll give you, what chapter exactly, but nothing beyond that. Even though we'll have class probably, after that, so, at least once. Okay.
You said it was 2 o'clock? 2?
Well, that's 1:30, I think I'm doing it.
Okay.
In OV 36. Okay. So let's do an example. We'll keep that over there. Okay. Let's look at the following equation. X squared, second y with respect to x, minus 2x dy dx, minus 4y equals 0. Okay? X squared y double prime minus 2x dy dx minus 4y equals 0. That's a Cauchy-Euler equation, right? Because second derivative x squared, first derivative x, and then zeroth derivative, of course, x to the 0, which is 1. Okay. So we know that the solution can be obtained in the form y equals x to the r, where it's a power solution, right? We're going to crank out a few derivatives here, right? Y prime is r times x to the r minus 1, and y double prime is going to be r minus 1, x to the r minus 2. Okay, now I'm going to do something now, which later on I'll drop because you can see how x to the r always goes out. But when you do your first problem, you don't want to skip that step. Okay? So x to the r, those derivatives are obvious. Okay. What about the first term? X squared y double prime. What happens? R minus 1, x to the r. Right? We're hit with x squared. So I get r minus 1, x to the r. Okay? Minus 2. What happens to x dy dx? R x to the r. And then minus 4 times what? Y, which is x to the r, is equal to 0. Okay? And what's going to happen in every case is that the x to the r is going to appear in every term because of the fact, just think about it, when you take your second derivative x squared, so it becomes, see, x to the r. First derivative times x, x to the r. So after a while, you'll probably just drop x to the r, okay? But first time I want to do it, obviously this means what? R squared minus r, right? Divide by x to the r, that's out. R minus 1, r squared minus r, minus 2r minus 4 equals 0. So that becomes r squared minus 3r minus 4 is equal to 0. You can factor that into r minus 4, r plus 1 is equal to 0. Right? Okay, so what are the roots? The first root is 4, and the second root is negative 1. They're distinct, so it's just x to the r1 and x to the r2. And as someone pointed out before, we have superposition. General solution is C1 times the first homogeneous solution, which is x to the 4th power, plus another constant C2 times x to the minus 1 power. Okay? And what's interesting about this equation, obviously, is that you cannot specify initial conditions at x equal to 0. It's what's called a singular point. Okay? Okay. And we'll do another example over here. Cauchy-Euler. Keep that over there. And again, you may want to say, you know, do x equals e to t, and I think you'll see, right, just think about it, you'll be doing much more work than just plugging x to the r, right? You got to use a chain rule and stuff like that, and then get constant coefficients, solve that, and then go back, okay? So this thing allows you to just say, I know a solution is the form x to a power.
The R powers for our x's doing the derivatives, you're plugging those directly back into.
Oh, yes, yes, yes.
And that's why it, the x squared can't, well, that cancels, but goes out with a -2.
That's right,
Negative
exactly.
zero.
Yeah, yeah, and this can happen all the time.
So it's one of the other concepts.
So let's do example number 2. Okay. I have 4x squared, second derivative of y with respect to x. That's good. Plus 8x dy dx. Plus y is equal to 0. So left-hand side, 4x squared, second derivative, plus 8x first derivative plus y is equal to 0. Okay? And I'm just going to take the algebra from here. Assume the solution y equals x to the r, right? All that stuff is still the same. So what happens now? I get 4 x squared y double prime. So see? X squared y double prime, r minus 1. And now I'm going to leave off the x to the r, because you know it's going to happen. Every term is going to have an x to the r in it, so you know, just save some work. 4 x squared y times r minus 1 plus 8. Now I need x dy dx. X dy dx just gives me r x to the r. Okay, that'll go out. And then plus y, you have to be careful, plus 1 equals 0. Now how did the y become plus 1? Because y was x to the r, and then you divide it through by x to the r. So now we get a quadratic, 4r squared, 8r minus 4r is plus 4r, plus 1 is equal to 0. So we've got factors like this. All right, 4r squared plus 1, yeah. Okay, so we got a double root over here, right? R1 equals R2 equals negative a, plus negative half. Yeah. Okay, so we have to do the case of a double root, okay? What to say about a double root? In our case, the double root is negative a half. So apparently your solutions will be what? X to the minus 1/2. That's one homogeneous solution. And the second one is x to the minus 1/2 times the log of x. So the general solution to this equation, I of x, is c1 x to the minus 1/2 power plus c sub 2 x to the minus 1/2 times the log of x. Of course, you can, if you wanted to, you could write that, I guess, as 1 over radical x. That's right. c1 plus c sub 2 times the logarithm of x. Okay? No, actually they finish. Okay. Let's do examples. Obviously, what am I doing? I'm trying to get like every type of equation. I'm just that over there. Let's do example 3 now. Okay, 4x squared, second of y with respect to x, plus 12y, no, 17y. I remember this one, 17y equals 0. Okay? So you got 4x squared y double prime plus 17y equals 0. And this actually is an initial value problem. We want to do y of 1 equals negative 1, and y prime of 1 is equal to a half, negative a half. So the equation is 4x squared, second y with respect to x, plus 17y equals 0. Y of 1 should be negative 1, and the derivative of 1 should be negative a half. That's an equal dimensional equation, right? Because you got x squared second derivative. Okay, in this case it's 0 x dy dx, that's okay. And 17y is fine. Okay. So what do? You assume a solution of the form x to the r, right? Y equals x to the r, right? Y prime is r times x to the r minus 1. Y double prime is just r minus 1, x to the r minus 2. So you can add the 4. Okay, so let's write down the auxiliary equation. 4, what happens to x squared y double prime? It's going to be r minus 1, x to the r. I'm going to divide through by x to the r, so 1 is 4. r minus 1, plus 17 equals 0, right? It's 17x to the r, but I do knock out the x to the r. Now we get a quadratic that we're faced with. 4r squared minus 4r plus 17 is equal to 0. Okay, we have to solve by the quadratic formula, I guess, right? It would be 4 plus or minus the square root of 2 squared minus 4 times 4 times 17 all over 8. Okay, so that becomes 4 plus or minus the square root of 16. Let's factor out 16, 1 minus 17. See that? 16 times 17 all over 8. So we get 4 plus or minus, that's under the radical what? Minus 16 quantity squared. So I get 16i over 8. So I get complex roots, right? The roots are going to be a half plus or minus
I think it's
2i.
Is it 8i?
No, because it's 16 times 60. See, 1 minus
Oh.
17 is 16, so it's 16
Right.
times 16. Okay. Half plus or minus 2i. Okay. So, what's the general solution? Y of x. I got complex roots, right? So, remember the root is alpha plus or minus I beta. The alpha is the real part, which is the half, and the beta is 2. So, I get one solution that looks like x to the 1/2, or the square root of x, right? Cosine of 2 log x, right? There should be a constant in front of that, sorry. C1 radical x cosine of 2 log x. And the second solution, c sub 2, would be x to the real part of the root, which is again radical x. And it's going to be sine of 2 log x. Okay. Yeah, I'm running out of time, so I'm not going to do all of the algebra. Okay. And I think it's reasonable that you can do the rest of this, but I'll give you some intermediate results over here. Okay. Okay, so what's y of x? Again, since you have to do dy dx at 1, let's simplify this a little if we can. So y equals the square root of x, right? C1 cosine of 2 log x plus c sub 2, radical x is outside, sine of 2 log x. Okay. Let's apply the first initial condition over here. What's y of 1? Okay, so I take my y of 1, okay, square root of 1 is 1, okay. I think I get c1, right? Because over here, log of 1 is 0, cosine 0 is 1, and then you get sine of 0. So c sub 1 is y of 1, and therefore that equals negative 1. Okay? And now we have to get c sub 2, okay? So let's differentiate dy dx. Kind of a pain in the neck, right? But, okay. Let's use the product rule. That becomes 1/2 x to the minus 1/2, right? If I differentiate x to the 1/2, and then I got that c1 cos of 2 log x plus c sub 2 sine of 2 natural log x. Plus now, what happens? I got the square root of x, and now I have to differentiate this term over here in the brackets. Cosine is a minus sign. I get a minus 2c1 sine of 2 log x divided by x. Let me see if that's C1 cosine is a minus sign of 2 log x equal to 2 over x, okay? Plus 2C2, pure sine is cosine of 2 log x. The derivative of 2 log x is divided by x. Okay. And you know, clean this up because a lot of things can go to 0. Okay, what's y primed at 1? Okay, plug in x equal to 1. Let's see what happens. That looks like a half over there, right? Okay, half. Let's see. When I plug in 1, that goes to 0, and that goes to c sub 1, right? Okay. When I plug in x equal to 1 over here, that's 1, that's 0, and I get 2c2. Okay? But we know the value of y primed of 1, it has to equal negative a half. Okay? So, what's 2c2? 2c2 equals negative a half. 2c2 is negative a half minus a half c1, but we have the value of c1. So it's plus a half, which is 0. Okay? So c2 is equal to 0. So the solution, the final solution to this initial value problem, you plug in c2 equal to 0, and c1 is equal to what?
Negative.
Negative 1. Okay. So you basically get negative radical x cosine of 2 natural log x. Okay? That will solve the differential equation and also the right initial condition. Okay, there's a few more problems which I'll probably do on Friday then keep you here. Okay, so but we've done enough. I'm probably going to post 2 homeworks. Again, not going to collect them. One will be on the variation of parameters, and one will be on this topic. And I guess I'll see you. Unfortunately, we're missing. Yeah, we'll miss next Monday and next Wednesday. I'll see you the Monday afterwards. And certainly by then I'll have an estimate of when my plan will be. Okay? Oh, so it's